Okay, grade 9, last weekend before Christmas break, and I know the last thing you want to do is study for a test, but this is your last section, section 7.3 on dividing polynomials. Your first question says, explain how you would perform the following division statement. So 3x squared plus 6 divided by 2x. So what you should probably say is that each term, it has to be kind of like distributive property of division, where you have to divide each term by 2x. Just like if you had multiplication in the last chapter, you had to multiply both terms by 2x. Here, if you divide by a monomial, each term in the first polynomial must be divided by the monomial. So what we want to do here is we'd want to take that first term and we want to rewrite it like this. And then we're going to take that second term, which is positive 6x, and it's sometimes good to put your positive symbol there, divided by 2x, and we're just going to divide them out. So 3 divided by 2 is 1.5. X squared divided by x is going to give you 1x left over 1. This is going to become just over 1 or just 1. So we don't really need to write that part. We just keep it as 1.5x. 6 over 2 is going to become 3, and x over x is going to become, if you wanted to put a 1, you can, but we'd like to think of it as canceling each other out, leaving us with 3. Since it's a positive 3, our answer would have been this. So what is 3x squared plus 6x divided by 2x? The answer is 1.5x plus 3. In the second question, it says Anita used the following method to simplify an expression. So she had this particular question to start, and then she broke it up just like we did in the last one into 9x squared divided by 3, and take away 3x or 3k divided by 3. But she ended up with 3k minus 1, and she was wrong. Because when we think about what is 9k squared divided by 3, here we're going to end up with 3. But since there is no k's down here, the k squares don't disappear. We end up with 3k squared. And the 3k divided by 3, which is the second one, those would cancel each other out, leaving me with a k, not a minus 1, or actually, sorry, minus k, not a plus k. So that's the solution she should have gotten. Question 3 says, use a model to show a polynomial division statement with a quotient of 3x plus 2. So 3x plus 2 is a quotient is your answer. Remember, that area of a figure, of a rectangle, divided by its side will always equal the other side that you don't know, the second side. So the quotient means the answer. So I'm really looking for this. So the answer, I'm going to put 3x plus 2 here. So 1x, 2x, 3x, plus 1, plus 2. And it says show any division statement. So I'm just going to keep it simple. I'm going to put an x here. Okay, and then I'm going to fill in all of the blanks. And you can have something different. If you had something different, that's great. These are all going to be positives, and these are going to be positives. So the division statement I had with a quotient of 3x plus 2 is 3x squared plus 2x divided by x, which is right here, will equal, the quotient will be 3x plus 2, or the missing side length. So the area divided by the side I know will equal the other side. And you could have different answers. There's infinite possibilities. Probably a lot of you kept it simple and probably did that one. Question 4a says, what division statement is represented by the algebra tiles and determine the quotient? So you don't have to draw it. You just have to say, okay, so here's the area. So the area divided by the side I know will equal the side I don't know. So the area is 6x squared plus 4x. That's the area. Divided by the side I know, which is 2x, will equal the side I don't know. And now I can simply put it in here. That's going to be x, 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 positive 1 and a positive 1, because a positive x times a positive x gives me a positive x squared. So the one I don't know is going to be, I know this is messy there, but it's going to be 3x plus 2 is your answer. Okay, that's the first one. In the second one, B, we have the area is 4x squared plus 6x divided by the side I know, which is 2x. And this time, when I work that out, I'm going to shrink this down a little bit here. When I work that out, I'm going to have a positive x here, because a positive times a positive is a positive x squared. Positive x here, positive 1, positive 2, and positive 3. So the answer is going to be, the side I don't know is going to be 2x plus 3. So 4x squared plus 6x divided by 2x is going to equal 2x plus 3. And finally, our third model, it's going to be the area, which is 6x squared minus 3x divided by the side I know, which is 3x, will equal the missing side. So here we have a positive x, because a positive times a positive gives me my positive x squared, another positive x. And here we have to have a negative 1, because a negative 1 times a positive x gave me this negative 1x, or negative x. So the answer for the missing side length would be 2x minus 1. In the fifth question, determine this division statement. So again, we have the exact same thing. We have a negative x squared minus 4x divided by the side I know, which is x. And when I fill in what I don't know, this is going to be a negative x because a negative times a positive. This is a negative x times a positive x. Gave me this negative x squared because a negative times a positive is a negative. This will be a negative 1, a negative 1, a negative 1, and a negative 1. Because a negative 1 times a positive x is a negative x. So therefore, the missing side length is a negative x minus 4 would be your quotient, or your answer to the division. In B, we have 8x squared plus 12x divided by the side I know, which is negative 4x. My missing side here, this is interesting because these two have to be negative, because a negative x times a negative x is going to be that positive x squared tile, because a negative times a negative. So we have negatives up there, and these also have to be negatives because a negative times a negative is a positive. So what we end up for our quotient is negative 2x's and negative 3, not negative 3, but just negative 3, not negative 3x. Okay, that's the answer to there. And finally, C, we have negative 3x squared plus 15x divided by the side I know, which is negative 3x, will equal, again, this has to be positive because a positive times a negative gave me that negative x squared. And these all have to be negative, negative 1s. So the answer is an x and minus 5. Question 6, divide each expression using a model. So the first one, 5x squared minus 10x equals 5x. So the first thing I'm going to do is I'm going to take my 5x's and I'm going to put them up here. So I'm going to put one of my side lengths in. In this case, I'm going to put my 5x's in. And once I do that, I then have to figure out how do I get my area of 5x squared minus 10x in. So to get 5x squareds, I can put them all in here like this. And once I have my x squareds, then I have to figure out how to get my negative 10x in. And that's going to look like this. There's going to be negative 1, negative 2, negative 10x. And once I have that, now I have my area in, I have my one side, and now I can figure out my missing side by placing an x squared in here, or an x, excuse me, and a negative 1 and a negative 1. So the answer for this, based on the model I just drew, will be an x minus 2, okay, based on the model. Okay, the second question. So here we have a 4x squared plus 12x divided by 2x. So again, the first thing I'm going to put in, this time I'm going to do it down this way. It doesn't matter which side you do it in. You put in your missing side, so, or one of your sides. So I know that 2x is one of my sides. And I know 4x squared has to fit in here. So the only way I could fit 4x squared is to put 2 next to each other like this. And then 12x is going to have to look like this. And once I have those 12x's in, 12x's, now I have 4x squared and my 12x's in. And now all I have to do is figure out what is my missing side. So here I have an x squared and x squared again, because x squared and x is going to give me those positives. And these are all going to be positives. 1, 2, 3, 4, 5, 6. Those are all positives. So I end up with an answer of 2x's and 6, or plus 6, as my answer. Question 7 is the same thing. So this time I have 4x's here, so I'm just going to use my top part. 1x, 2, 3, and 4. And then I'm going to put my area of negative 8x squared, so I can put 4 on this line. And then I'm going to cheat and put 4 more by cloning it. I know you guys can't do that. The advantage of using a smart board. So there's my 8x squareds. Then I have to have a minus 4x. So the only way I can do that is to put a minus x here, a minus x here, a minus x here, and a minus x here. When I do that, I end up with a negative times a negative, a positive times a negative, so a negative there, and a positive times a negative is going to give me that side there. So the answer to the first one will be negative 2x minus 1 for the missing side length, right? The area divided by the one side I know will tell me the side I don't know. In B, Negative 3x squared plus 5x is going to be area, but before I do that, I'm going to put one of my side lengths in, which in this case is going to be a negative x. Now I have to fit in negative 3x squareds to that, so I have to build my negative 3x squareds straight down. So I'm just going to put them in here, and then positive 5x's. I'm going to use these. And once I have that put in there, now I have to figure out what my missing side lengths are. So a negative times a positive gives me a negative. So these all have to be positive x's, because a negative times a positive is a negative. And these here have to be all negatives, because a negative times a negative gives me that positive. So a negative, and a negative, and a negative. And this takes forever. And a negative, and finally a negative. So my missing side length, when I draw it, is going to be a positive 3x minus 5. Question 8 simply says divide. So for this one, you just want to use your basic division method. You probably don't want to model this. So again, we're going to divide both terms in the binomial by 2y. I'm going to rewrite each part like this and like this. And then I'm simply going to simplify. So 2 over 2 is going to be 1 over 1. Y squared over y is going to become a y. That's going to equal y. 4.2 divided by 2 is 2.1. Y divided by y cancel each other out, so it's going to be a plus, and therefore I have my solution of y plus 2.1. In the second one, I have to write it 3 times, so I have this, I have this, I have this, and all 3 I'm going to simplify them. This is going to become 6m squared. This is going to become negative 3.1m, and this is going to become a positive 12. Okay, so we'd have that. In C, we have a negative 18y squared divided by that negative 6y. We're going to use that here. And we're going to have, now notice how I keep the subtraction sign with that negative 6y here. So it has 2 different terms. So negative 18 divided by negative 6 is a positive 3. Y, because a y squared divided by y would be that. Negative 6 divided by negative 6 is 1. Y divided by y is 1. Now, it looks like there's nothing there, but there is a 1 there. So it's actually going to be a positive 1, because a negative divided by negative is a positive. So we are going to have a plus 1 there. It doesn't become nothing. It becomes 1. Negative 6 divided by negative 6 is 1. Y divided by y is actually 1. We don't put 1 because we don't need to, unless it cancels everything out. In this case, we do have to, and it becomes 1 times 1, which is still 1. And finally, D, 3CV divided by 3C, and a negative 2.7C divided by 3C. 3 divided by 3 will cancel each other out. C but divided by C, actually, we can think of it as 1 and 1, 1 and 1. But 1 times V is still just V over 1, or V. Negative 2.7 over 3 is going to be a negative 0.9. C divided by C becomes 1, or if I can put a 1 there, but it doesn't matter because it doesn't affect it. It's still multiplication, and I end up with a final answer of V minus 0.9. Question 9, some more of the same thing. I'm just going to put all the answers here for you. Actually, as I was writing the answers, I thought, you know what, I better show you this one. So I'm going to write this one out here for you, and a negative 1.5 st over 5s. And this one here, I'm going to draw your attention to it now. The negative s squared does have a coefficient. It's negative 1. So when I really think about what this is, negative 1 over 5, that's going to work out to be 0.2, a negative 0.2 s. Negative 0.2 s. I better get rid of that equal sign and just, okay, equals negative 0.2 s. So this here, I have to really see that 1 as being the coefficient, because then I can do 1 divided by 5 to get my refined coefficient of 0.2. 1.5 divided by 5 is 0.3, or negative 0.3. The s and the s cancel each other, leaving me with a t. So my simplified expression, better put that in there, is negative 0.2 s minus 0.3 t. It's a fairly complicated one. And if I look at the last one, I'm going to write it out. Negative 14w squared over 0.5. Negative 7w over 0.5, and finally 0.5 over 0.5. All right, first term, negative 14 divided by a half is going to be a negative 24. W squared, there are no w's down here to cancel each other out, so the w squares stay. Negative 7 divided by 0.5 is negative 14. The w stays. and this becomes 1 or a positive 1. So my refined solution for D would be negative 24w squared minus 14w plus 1. Question number 11 is a rectangular fish tank has the dimensions shown in meters. The volume of the tank can be represented by the polynomial negative or 7.5w squared minus 3w. What polynomial expression represents the area of the base of the tank? Okay, so in order for us to solve this, we had to know that length times width, the area of the base multiplied by the height, gave me this volume of 7.5w squared minus 3w, because that's how we get volume. And since the volume is that, I know my L is, I don't know it, so I'm going to put question mark, multiplied by w, multiplied by 0.6, okay? So really, in this case, I know 2 of my sides, and I don't know this one. So that's kind of like if I take the volume and multiply it by that which I know, I will figure out what I don't know. So w times 0.6 is 0.6w, or a monomial. So in order to find that missing side length, all I have to do is use this idea of division of a binomial by a monomial. Rewrite it here like this, and rewrite it over here like this, and then simplify it out. So 7.5 divided by 0.6. So 7.5 divided by 0.6 is 12.5 w. So 3 divided by 0.6 is going to be 5. So negative 5, and the w's will cancel each other out. So that has to be the missing side length right here. So it's going to be 12.5 w minus 5. I think that's what it was, minus 5 or plus 5? Minus 5. Okay, so now we have that. That says what expression represents, oh, the area of the tank. So the area of the tank would have been the multiplication of those two, so it has to be, oh shoot, I fudged up there. Hang on a second. So volume divided by that would have got me this. Anyway, it still works out. We got that. We got the area and we got the length. We got them both at the same time. And now we're on to C, which says, what is the length of the tank if the width is 0.6 meters? So all we have to do is change this to 0.6 and change that to 0.6 and work it all out. Okay? So here's what we got. So area of the base would be this multiplied by this multiplied by this. Take away that. That's the area of the base. So if I work this all out with a calculator, this is the width and the length. So 0.6 times 12.5 times 0.6 equals, oh, I screwed up somewhere. Oh yeah, hold on, clear. So first I have to simplify this. So 12.5 times 0.6 equals 7.5. And 7.5 take away 5 is going to be 2.5. So really, when I simplify the length of this tank, it will be 2.5 meters. I already know the W, it told me, was 6 meters. So here, the volume of the tank will be 0.6 times 2.5 multiplied by the height, because area of the base times the height. Take my calculator out this time. 0.6 times 2.5, so the area of the base is 1.5, multiplied by the height, which is 0.6, and the volume of the tank will be almost a cubic meter of water. Now the other two questions, don't worry about them. You don't have to do them because they're not going to be on your test. So if you're trying to find the answers to them, don't worry about it. I will tell you that on your test you will have a question like this one. It'll be easier. We will do another practice question like this on Monday. So if you didn't understand what I said, because I babbled it quite a bit because it's Friday and I want to get out of here, we will work on it a little bit more on Monday when we come back. Okay, thanks for watching.